morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our expert panel, The Future of Retrieval-Augmented AI, a blueprint for scalable and cost-effective RAG systems, brought to you by our friends at Tecton, Nexla, and Galileo. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI community. Today, we're excited to welcome hundreds of attendees from all over the world to discuss how Retrieval-Augmented Generation, or RAG, is revolutionizing the way organizations harness the power of AI for precision and efficiency. Enterprises face significant challenges when deploying AI solutions, including the inability of large language models to provide context-specific responses, the risk of generating inaccurate or fabricated outputs, and the difficulty of keeping AI systems updated with dynamic information. Today, we'll learn how Retrieval-Augmented Generation, or RAG, addresses these challenges by dynamically retrieving relevant enterprise-specific data from trusted sources and incorporating it into AI-generated responses. We'll hear from industry experts as they share actionable insights into optimizing RAG architectures for enhanced performance, integration with existing data infrastructures, and the strategic choices driving innovation in this space. We're honored to hear from a distinguished panel of experts today. Han Wang, lead engineer of GenAI at Tecton, Amey Desai, head of AI at Nexla, and Naveen Pentakota, associate director of data science at Novartis. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features throughout the webinar. We'll be addressing your questions throughout the webinar, so be sure to upvote the questions you'd like the panel to address. If you're wondering where your organization stands compared to others on your AI journey, check out the poll question in the right sidebar. And finally, to learn more about how to leverage RAG in your AI journey, check out the calls to action below throughout the webinar from our sponsors Tecton, Nexla, and Galileo. Now, without further ado, I'll welcome our panelists to the stage. Welcome, gentlemen. I'm so excited to have you all here today for a great discussion about RAG and the future of AI. So we'll kick things off with some introductions. So if you could tell everyone a bit more about who you are, what your current role is, and keep it to about 30 seconds. So we'll dive into some of the more substantive questions. So why don't we start with the order that you appear on my screen, which is starting with you, Han.
Hello, everyone. My name is Han, and currently I'm the lead of Tecton's GenAI team, and I lead the vision and the development of the internal and external facing GenAI products.
Excellent. Welcome, Han. Naveen.
Hello, everyone. I'm Naveen Pentakota, Associate Director of Data Science at Novartis. I have a mixed experience between financial services and pharmaceutical industries and led many teams on data science and machine learning and AI. Currently working on AI-related products in Novartis, primarily for internal-facing and external-facing agents. Thank you.
Thanks, Naveen. And Amey.
Hey everyone, this is Amey. I am the head of AI at Nexla. I am a builder at heart, but at Nexla, I build as well as productize, strategize, especially around things on AI. I'm kind of excited to talk about RAG and share what we are up to. Thank you.
Thank you. Welcome, all of you. And we'll start things off with the basics. So for those in our audience who maybe have not implemented RAG or Retrieval Augmented Generation or are unfamiliar with the term, I just want to give a quick introduction to the concept. So if you could explain what is RAG and why you believe it is critical for enterprise AI strategies. We'll start in reverse order from where we just started with intros. So why don't we start with you, Amey?
So RAG stands for Retrieval-Augmented Generation. I would say kind of in a nutshell or in very, very layman's term, what Google Search did 20 years back, kind of ChatGPT has made it available for everyone to do, but on your unstructured data. Another analogy I like to share is what tabular data and SQL did many, many years back. Kind of LLMs are the same tool like SQL to unstructured data. So it allows you to capture information from documents like PDF files, audio documents that you potentially have, images, graphics, and being able to ask questions of that and get very reasonably accurate answers, which was just not possible a few years back. And that can create a very boost efficiency for all organizations that can leverage that.
Yeah, great overview, Amey. Naveen, anything to add there? And what do you see as being critical about RAG for enterprise AI?
So I actually see it as a slightly different analogy. I see that large language models typically have used a lot of data coming in from the internet and other sources. So I see that as a vast ocean of data where the enterprises lie in between somewhere in terms of the data infrastructure and also the availability of data at various levels. So I see that as like the ocean embedded with a lot of islands of enterprises, and the enterprise are able to leverage a large language model capabilities to weave a fabric of themselves for that particular island and develop their own technologies and in-house capabilities.
Thanks, Naveen. Han?
I agree with Amey, and especially when he mentioned about the structured data and unstructured data. I think the general purpose of RAG is to provide large language model with unseen data but necessary context information. Large language models are trained with limited amount of information, which I think we can call them base knowledge. And this base knowledge will make LMs to have common sense. But in order to solve specific problems, I think it is important to provide large language models with additional and domain specific, use case specific, or user specific information so that it can really solve the problem with the common sense or with its own capability. And I think one interesting thing is that currently, I think the RAG is generally related, is tied with semantic search or similarity search, which I think it's a very important type of search, but it's just a one retrieval method. There are many other retrieval methods that are equally important. And I think we shouldn't ignore different approaches to retrieve information.
Yes, excellent points, everyone. I want to turn to one of the central questions that we've been addressing in a lot of our webinars over the last couple of months, and that we'll be addressing frequently in 2025, which is the question of scale. So as you start to deploy RAG throughout an organization, especially large enterprises, the way that you do that at scale in a large enterprise may be very different or involve different challenges than simply doing a POC with a small number of users or a smaller amount of data. If you guys could just address some of the challenges that you think are specific to building scalable RAG systems that might differ from what you do in a POC context. Naveen, why don't you kick us off there?
Sure. So we have a few challenges coming in when we talk about scalability of the RAG systems, especially if you have to look at high information retrieval, right? You require a lot of volume of data coming in when the scalability increases. So that's something which you should always be concerned about. You have to manage a large data volumes efficiently, and at the same time, you should be weighing in data privacy concerns. So maintaining systems which are responsive even when user demand increases, that's also something very important. So these are some of the challenges which we have when we come to scalability of the RAG systems, and they should be at two ends of the RAG pipeline. And one is at the retrieval pipeline and also at generation pipeline. So as the volume of the data and the variety of the data and the velocity of the data increases, you should be able to capture all of the data and come up with real-time recommendations in some instances at least. And that's how the scalability also plays a role over there.
Yeah, excellent points, Naveen. Han?
I think first we need to clarify what scalability means. Because scalability for RAG can mean at least two very different things or two different directions. One is you have a large amount of content in one RAG or in a small number of RAGs. Or another direction is you have large number of small RAGs. So one is small number of large RAGs, large number of small RAGs. And practically, I have never seen any scenario with large number of large RAGs. So let's just talk about small number of large RAGs or large number of small RAGs. I think those two things will need totally different solutions in order to solve their scalability issues. I think I can talk more about this, but I think Amey may have some other things to add.
I think maybe there are two additional points, and I think both of you touched upon it a little bit. One is kind of just the diversity of data sources. I think enterprise systems, in addition to like the standard documents today, do have a very, very high amount of good data in databases, as well as in just internal systems that they have built. Unlocking them at scale, I think, is a key critical aspect. And that means you should be able to query structured data, semi-structured data, as well as unstructured data at scale in a real-time manner to get answers. One of the additional things that we have experienced is scaling collaboration, because your rack designer is typically an AI engineer or maybe a data engineer, but the end user of your product is more often not a business user or a non-technical user, and they need to collaborate with each other, and having a place where they can collaborate seamlessly is kind of important. Because for all the good things that evaluations that I think have happened with RAG, just human evaluation is probably the best thing that we can still do right now, even with kind of LLM as a judge and fine-tuned models and all of those things. And that human evaluation comes with this person who's using it and the person who's designing slash kind of building it. So they need a very tight feedback loop to iterate. And those are the two things that I think we have at least seen the maximum scale challenge come in today.
Yeah, excellent points. On the concept of scalability, and I appreciate, Han, the kind of the distinction that you made about that can mean a lot of different things in different contexts. But with respect to scaling this throughout an organization, there are a lot of cost concerns that come into play. Again, that at the POC stage may not be as relevant, and as you start to scale, those costs can add up quite quickly. So what do you guys think are some practical steps that organizations can take to optimize the cost of RAG implementations, particularly for workflows that are very inference heavy? Let's start with you on that one, Han.
Sure. So again, I think in order to optimize the cost, we need to understand, do we have a lot of racks, small racks, or do we have some large scale racks? I mean, with a lot of data. Like for example, if you have small racks or small scope of information that you want to retrieve from, then probably, I mean, for example, you can just deploy that small data set with your applications so that it's less stateful and it could reduce the operational cost. And on the other hand, if you have some racks with a lot of data and you have to serve them in a centralized way, and then probably you can think about tuning the indexing parameters and get a better trade-off between ingestion speed, latency, and quality. And on the other dimension, think about if some piece of info or some data set or some RAG, they're more static. You don't need to update them very often. And then probably you can put more emphasis on the indexing method. So you can spend more time to ingest and index the data so that on the serving side, you get lower latency, higher throughput. And if you have some RAG that you need to update frequently, and then it's a little bit more complicated. I think it's more case by case. And I think there is another important thing is to distinguish between batch and real-time case. Do you really need the real-time RAG serving? Or sometimes it's actually, like, for example, if you have, like, I want to search 10 million queries on a certain RAG, maybe with 100 million records. And then I think it's a typical batch case. And then the solution can be totally different. And with an appropriate solution, you can significantly reduce the cost. But if you still treat that as an online case and you are using servers to serve that RAG, and then the cost at the time can be significantly bigger than you expected.
Yeah, great points about the trade-offs and different considerations there. Mike?
So maybe talk a few examples that at least we have seen. So one is to kind of evaluate open source models and figure out if you were to deploy your own open source models, would you actually save on cost? And the comparison for that very well can be using a model like Llama on one of the serverless functions like either AWS Lambda or GCP Cloud Functions, and then kind of compare that performance with something like a GPT-4 or an Anthropic. And I think one of the key things to understand is your workload, similar to kind of what Hans said, how many real-time queries you're going to do. Is it going to be bursty where maybe in a couple of hours you get few hundreds of queries and then the rest of the day no one's really kind of going to use it? So understanding those workload patterns can also play a key part in doing the cost calculus of whether using a particular model makes sense or not. I think the other thing, in addition to, I mean, deploying open source models and using them is just generally a beneficial thing because then your data remains private. That's actually a very big boon. One other thing I'd say is over the last year, especially, models have gotten really cheaper by an order of magnitude cheaper compared to where they were when they started. A lot of your LLM tasks today can also be done by some of these smaller slash cheaper models. So breaking down your task into what are the parts of your task where, let's say, as an example, you can use GPT-4o mini to do it rather than GPT-4o, and then re-engineering your tasks to use GPT-4o only for some of the critical pieces can also make your pipelines not just cheaper, but also scalable, because the weaker or the smaller models are also faster for inference time. So those are, I would say, maybe a couple of tricks that organizations can leverage today.
Yeah, great points, Amey. Naveen?
Yeah, so just to follow up with what Amay was talking about, smaller models, also the specialized models will play a role over here. Even though the models may be smaller, the specialized role on data which they have been trained on can actually become very important for the task which you're working for, especially in like healthcare or finance kind of domains, where you require very specific kind of verbiage and language. That's where I think the specialized models will play a role. A second thing is that you can also do model pruning and quantization, especially once again on the model side, and you can do distillation also of the models to reduce computational overhead. And last but not the least, you can work on regularly monitoring costs and performance metrics, and while trying to parallelize the retrieval and generation tasks using distributed architecture.
Yeah, great points, Naveen. Amey, you wanted to add something?
Yeah, I just wanted to also maybe talk about also evaluate the cost of like engineering and the actual humans who are going to do those tasks. Even if, like, let's say you're deploying open source model that does require a development effort, a deployment effort to get it to function, and then over time also a maintenance effort. So it's a pretty kind of, I would say, nuanced problem to understand. And I think in addition to your workload, also knowing your data and kind of piggybacking on the Hans point about if you understand your data, then you can understand much more deeply whether it's a real-time use case, a batch use case, and how many dimensions of that data do you actually care about to satisfy your users. So it's just at those two additional points.
Yes, great points. Han, we had a follow-up in the Q&A section to a point that you raised about specifically scaling a few large RAG pools. So Gassan was wondering more information on how you would go about scaling a few large RAG pools versus lots of small ones. So can you provide some additional detail on that?
I think it's really case by case. For example, the first thing you could think is when you have a large RAG, do you think for every query going through that RAG or the vector database needs to search the full scope of the content? So have you thought about using metadata filtering, partitioning, in order to quickly scope down the data? Have you thought about breaking down, simply breaking down the large RAG into a few smaller RAGs? Those things are the basic first steps to think about this problem. Second thing is algorithm tuning. Like for example, hopefully your large RAG does not need frequent update, and then you can put more time or more effort on tuning the algorithm parameters so that it can build a better internal indexing so that on the serving time on the serving side the latency can be better, the throughput can be better. Again, I think it's really case by case. it's difficult to scale large racks. So first, think, why do you really need large racks? Can you break it down in some way?
Yeah, great points. Jumping to our next question, I want to talk about how you integrate RAG into existing enterprise data ecosystems. So if you've got an existing ecosystem with data lakes, data warehouses, cloud platforms, you can't necessarily reinvent your stack based on a particular use case with RAG. So how do you integrate RAG into those existing infrastructures, and what challenges are organizations likely to face as they do so? Why don't we start with you, Amey?
Sure. So I think one of the first big challenges is just having connectors to the enterprise systems that are present, so you can connect to them and are able to extract data, whether that's for indexing them or even kind of querying them in real time. I think additionally, a couple of challenges that we have seen at least are around managing computations at scale and ensuring that incremental computations do not trigger recomputing your entire indexing pipeline. So one kind of aspect of that is if you have a folder on S3 where you have your documents, if you update that folder, that should not trigger reingestion and reindexing and embedding generation for all those documents. So just doing incremental computation, I think, is a critical aspect. Other additional thing that I think will happen eventually is kind of migration effort across vector databases, where how easily can you make a migration of an index from within the same vector database or even for a different vector database. A large part of that is because there's an experimentation step that is needed for a lot of tuning for the indexing process to do. And you don't necessarily want to always start from scratch because it is quite frankly costly from a development standpoint as well as from a payment standpoint for some of these third-party services.
Yeah, great points, Amey. Naveen?
So I see that like managing data storage, avoiding data silos are also key components of this infrastructure assimilation for RAG systems to assimilate into our infrastructure. You have to maintain performance by integrating with existing systems, and this can be very resource intensive. So as Amey actually mentioned previously as well, this is something which we should be looking at, like structured data, semi-structured data, unstructured data. All these types of data has to be harmonized, and there should be a layout for both storage and retrieval. So if we have systems like that in place, I think we can integrate the RAG systems successfully into the enterprise, because we should also consider other considerations like data silos, and also like what kind of role-based activities do we have for the different data sets. So all those things will play a role in understanding what kind of limitations we can remove from the layers which we typically have inside the data structures, and how can we integrate them into a more harmonized point of view for the data perspective.
Yeah, data silos, of course, a critical point as organizations try to give their models context. If you're not getting the full context because your data siloed, that's obviously a big challenge. Han?
Sure, I can think of a few challenges. The first challenge is, how do you keep data in sync, right? When you try to keep data in sync from your data source to the vector database, and then you need to build some sort of pipeline, and then you need to maintain it. And as Amey mentioned, that it's better to be incremental update. So actually, to be more general, you want to build something that's continuously updating your index, right? So that the continuous pipeline itself is a stateful pipeline that is very difficult to maintain, and the operational costs can be high. And to add information to add records into the vector database may be okay, but how about the removals? Like today, you need to add 200,000 records and remove 20 records. How can you identify the records to be removed? Actually, that's even more complicated to solve. I mean, it's totally solvable, but it's just complicated. The second challenge is that, so if you think about the indexing algorithm itself, actually it's vulnerable to a sequence of updates. The more times you update, you do delta update, on the index, the quality will just get worse and worse. So that means you need to decide when to re-index the whole thing, because you see the degrade of the quality. And then also that will also require you to continuously monitor your system so that you get a signal where you need, or when you need to re-index. So in general, I think it's a very complicated problem.
Yeah, great points. And just to double click on that for a second, Simon in the audience has a question of who curates the data going into the RAG, and it's a critical point in light of what you guys just mentioned. Is, you know, if you've got concerns about data access or data quality, how do you address those concerns before you put that into the model? What specific steps can organizations take? Any of you guys want to weigh in on that one?
I think it's typically the combination of your data engineering team, which is actually going to do the data processing that needs to manage your RAG. But you also need a domain expert that's going to kind of almost oversee that information and guide them around what data is going to be most critical to their users to answer it. I think the ensuring of whether the data is garbage in, garbage out or not, I think that's what I meant is a collaborative process between your end user as well as the person who's kind of building the data ingestion pipeline. And I don't think you know this answer upfront. It's kind of an experimental / iterative process, and then eventually it amortizes to becoming kind of consistent. One of the key things also to ensure that data in, data out is not garbage, is just having automated pipelines. I think if it's a manual effort where someone's doing it on their laptop with some open source library and pushing it, there's a very high chance of failure. So going more towards enterprise grade systems is, I would say, critical.
Yeah, great points. So I want to jump to our next question, which is on the topic of security and compliance. Organizations are feeding their models with sensitive data. How do they ensure that they maintain adequate security and compliance and privacy when retrieving that external and internal data for RAG-based applications? So why don't we start with Naveen on that one?
So on that front, once again, as I mentioned, you should be looking at data at a role-based access, right? So you have to give access to one of those hands which will be important to handle the data, and not every person can get hands on the same data at the same level. So this is actually a kind of a catch-22 kind of situation, weighing in with the previous challenge we're talking about, where it's system compatibility and accessing enterprise data versus this ensuring data security, because data security can actually happen at multiple levels. It could be at a data security level, network security level, or at a cyber security level as well. So you should be aligning your systems in place and making them work with each other so that they also comply with external regulatory authorities like GDPR, CCPA, HIPAA kind of systems. And also, like, when the prompts are being ingested into the system, you should be making sure that there are no breaches of data, there's no pulling of data from your systems, or such prompts should be invalidated. Any prompt injection attacks, as you call them, also should be invalidated. So these kinds of monitoring has to be done on a real-time basis, and there should be systems in place and guardrails to understand that RAG systems are not leaking out data and giving the data into the wrong hands.
Yeah, great points, Naveen. Han?
So actually, I think security is a very, very important thing for RAG. And I forgot to mention that before I joined Tecton, I was the lead of AI and ML platform at Lyft. And we have a very concrete case where we have a very specific security need. So thinking about that, you have 10,000 documents, right? So 10,000 maybe not a lot, but the problem is our users, they have different access. I mean, permissions to access different subset of the 10,000 documents. So how do you solve that problem? I mean, if you want to put everything in a single RAG, and then person A can access maybe 2,000 of them, person B can access 2,000 of them to another 2,000 of them. So it's a very, very difficult thing. So I know there are two approaches in general. One approach is like brute force. What you can do is like based on different access, different roles, you can just replicate the documents. For example, for this role, I will build a rag of 6,000. For another role, I will build a rag of 4,000. I know some companies are really doing that, but this approach really has too many drawbacks, and it's really, really difficult to maintain. So unless you are 100% sure about what you are doing, and this is probably a simple way to solve that problem. So another approach is more similar to like metadata filtering, but the challenge is you have to map your rows to certain keys or categories, and then you need to manually build this kind of categories into your rag. And when you do the search, you have to enforce some of the metadata filtering. And this approach also has a lot of issues. For example, if you have too many categories, and actually, if you look at the algorithm the common algorithm of nearest neighbor search, and they will know that we have a lot of metadata filtering. Actually, the quality will downgrade. So how can you solve that problems? I know certain vendors, they have special handling, they have special algorithms to improve the quality, but I'm not sure if every single vector search solution has that equal level of handling to ensure the quality is still good. Yeah.
Great points, Han. Amey?
Yeah, so I think to add to Han's point, I think there are like maybe three key components to executing something like this, right? One is you need an enterprise system that can understand the existing ACLs that are already built within that enterprise, whether that is a Microsoft LDAP, whether that's a Google Workspace, Okta, any one of those. So just being able to tie that access control to the document level kind of allows you to at least be able to answer this question. A canonical problem that we have had is row level ACLs. I think with RAG, what problem we need to solve is chunk level ACLs or chunk level ACLs. And then the third part to kind of complete the puzzle is when the user is querying, and not just in addition to the question, you should also be able to send compliance specific information where the client can send, hey, this user is part of group X, and check if they can actually answer this question. And then it's the RAG system's responsibility to, I would say, do compliance-based dataset search and first figure out, can this user even answer this question or not? So that's kind of one way you can maintain isolation as well as security. I think in terms of compliance, I think everyone's talked about the guardrails and prompt injection and hacking that's continuously, I think needs continuous work and continuous monitoring to be able to do it. I think one additional point I'd make, and this is kind of a pro and a con of the entire LLM evolution. Everyone's kind of started putting docs in RAG and people kind of start asking questions. And certain answers kind of suddenly open up the sensitivity of the information. For example, various startups, if they have all hands and then do competitive strategy planning, or their ARR numbers and those presentations kind of, let's say, go in a chat bot where anyone can ask those questions, someone at your org may be able to get information that they were maybe not supposed to do. And that is kind of the sensitivity level of the information itself that's getting presented back to the user. I think in addition to the vulnerability scanner, sensitivity slash confidentiality scanner is kind of necessary for organizations to maintain security and compliance. And this is again a place where something like a fine-tuned model would actually go a long way because you want to maintain very strict isolation for data of this nature. So chunk level ACLs, I think, is a bare minimum that I think most vector databases will eventually start doing. If not, metadata filtering is a very good way to be able to do this today itself.
Yeah, excellent points, Amey. I want to, with our next question, take a step back, more of a 20,000 foot view, and talk about where we see this going. How do you see RAG evolving in the next 2 to 5 years? Obviously, these are relatively new technologies, at least in the enterprise context, certainly with organizations leveraging RAG for the first time in the last just several years. So how do you guys see these evolving in the next several years as these technologies start to become more mature? Let's start with you, Han.
I think one very important thing is that currently the importance of unstructured data is overstated. The importance of structured data is understated. So I think in the next few years, people will realize that the structured data is equally important or even more important. So RAG doesn't mean retrieval from vector search. It means retrieval in many different ways. So I think that's one thing I predict. And I think another thing is people will pay more attention to the ETL, the path before ingesting into something that's for serving. So from your raw data to something that's servable for retrieval, I think ETL pipeline is a very big challenge, and I expect to see some very good solutions and unified solutions on that. Yeah.
Good point, Han. Amey?
I think one thing I maybe predict, I would actually like to co-sign what Han said. I think structured data is kind of where most organizations have their knowledge bases captured. And that would be much more critical to make a RAG successful. One thing I would think would happen is currently today it's a very chatbot-like experience where you ask kind of question and answers, and it's still a little bit more in the exploratory territory. I think you will get more prescriptive chatbots, which would be kind of templatized to solve a particular task. And I imagine RAG as being kind of one of the nodes in an agentic workflow that most systems will have, and would probably be the node that drives most actions. Like it's kind of almost like the action originator in the entire agentic system as kind of things evolve in the next couple of years. And I would say last is it will get faster and faster. I think people expect faster answers. Right now, I would say large RAGs are kind of too slow, but over time, I expect them to get quicker.
Points, Amey. Naveen?
As I can see, at least as of now, right, in the next 2 to 5 years, I think multimodal retrieval systems will become very much prevalent in the industries, with a lot of applications coming in, and also like multilingual RAG systems will play a role because of the language intensity with which we are trying to mingle different cultures and societies, right? So that's going to draw that democratization of or sovereignty of data sovereignties as we're speaking about. That's going to reduce a bit, and multilingual RAG systems are going to evolve. That's one of the things which I'm foreseeing. And also like computational advancements are going to make RAG systems much better to work with. And as both of my peers over here said that they talked about structured data being infused into RAG systems. So that's going to play a very big role, because that's where the insights are going to hit the table, and that's when we can make real decisions out of the RAG systems immediately.
Yeah, great points. Han, you wanted to add something?
Yeah, so someone was asking like a RAG vs agents, which do you prefer? Actually, I don't see the conflicts between those two at all. I think in the next few years, I think RAG as tools, instead of just directly using RAG to enrich your prompt, will be more popular, will be more useful. Actually, for both my current job and my job at Lyft, we have extensively using RAG as tools in the agentic system, which is a way better way to use RAG than just use it in the static way to enrich your large language model.
Yeah, very good point there. Another point that I want to get to is just a question of latency, and you guys alluded to it. Amey, you mentioned that you think RAG models are going to get much faster. So one question is, as organizations start to deploy RAG in more of an enterprise context, more scalable type applications, latency is going to be a concern, and there are going to be situations where real-time processing is needed. So can you guys just speak to that? How do you balance the need for reducing latency while also maintaining output quality? What are some of the considerations there? Naveen, why don't you start us there? You're on mute, Naveen.
Sorry. Yeah, so the way I see it is that there's going to be adaptive retrieval mechanisms which are going to help increase the RAG applications with reduced latencies, so primarily for real-time RAG applications. And then also you would see that streaming is going to become a lot more important, because if without streaming, there's going to be a lot of perceived latency, even though latency might be the same in two systems where you don't have streaming and where it's going to have streaming. So that's one other factor. And the last winner is going to be like pre-chunking and embedding data into vector stores for faster retrieval, which we're doing currently. But that's also an important way how to do it, and why you should be doing it is the flavor which you need to add on a case-by-case basis. And that's what is going to help you improve your latency in the systems.
Yeah, great points. Amey?
I would say one important thing is ensuring that your chunking is not something that is a default state, and having a little bit more dynamic chunking that can understand your user's pattern and workload is going to be more important. Certain question answers are just like one lines. You don't need a big chunk for it, but you can't also have like a default chunk of either 512 tokens or something along those lines. I think agentic chunking would become more and more prevalent. One of the, I think, key problems here also is, I'm just answering the question that is being asked in the chat to take the time. You would have some notion of an orchestrator that kind of decides how do you even like parse a file correctly. For example, you don't need to parse every file with a state-of-the-art parser. Some just have text. So parsing that text, I think, is kind of important. Utilize. So those are two things that I do actually see making a difference to latency. The other is just using metadata filtering very, very smartly. And I think that requires building kind of your own, almost like a pre-RAG engine or a pre-relevance engine, so that you can figure out what are the right metadata filters to use, so that you can look at a much more narrow scope of documents when you're trying to answer questions. And I think lastly, and this requires a lot of effort, fine-tuning open source models that can solve very specific use cases that you have can go a long way in reducing latency overall.
Great points, Amey. Han?
I think in terms of latency, there are two parts, right? One is retrieval, another is generation. Like, I think practically speaking, like if your generation takes 10 seconds, then your retrieval taking 1 second or 0.1 second, it doesn't make a big difference, right? So I think if we're talking about the system latency for the whole rack system, I think it's majorly on the generation part. And in order to solve that, I think you should think about chunking. You shouldn't provide too much information. But on the other hand, if you don't provide enough sufficient information, the large language model can have bad performance, right? So I mean, it's a trade-off. And I think maybe the strategy is to be more domain specific and use less powerful but fine-tuned models to solve domain-specific problems. And then on a higher level, you probably can have an agentic workflow to work with many different RAGs to solve this problem collaboratively. I think that can be an effective way to reduce the overall latency.
Yeah, great points, Han. We got a good question from Ajay in the chat. I wanted just to raise this for a second. Do you see LLMs, GenAI, or RAG hitting the crest and not being accurate enough for many business uses, leading to it getting deprioritized by business, at least temporarily, until a breakthrough is achieved? So I think this is a critical overarching question that's being discussed with respect to AI generally right now, which is for some of these enterprise use cases, how accurate is accurate enough? Even increasing the level of accuracy and reliability in context that you get through RAG, is that going to be good enough for some of these enterprise use cases, particularly in highly regulated industries, or if you're dealing with sensitive data or very questions where it's very important to get the right answer, and maybe 90 or 95% accuracy is not good enough. So what are you guys' thoughts on that? Why don't we start with you, Amey?
I think this is a very fair question. It's also a very great question. I foresee that not happening though, even though I would say we have seen kind of RAG not being accurate enough in a lot of use cases. I think a large part of that is we are not able to give the right data, or we don't have the best systems yet for users to be able to provide data to the LLMs to be able to get it more accurate. So over time, I do expect them to work better. I think it's also an important responsibility for the engineering or whoever is kind of building it to ensure that you don't have very obvious failures. Like I sometimes call them as like the bro failure or the bro failure, where somebody just asks a question, they say write hi, and it says I cannot answer that. Like lose faith and trust very very quickly within the system. So I would say that stick to that, and additionally, putting in kind of the right product intuition, the product signals around a simple note like, hey, this is an AI system, it can hallucinate from time to time, so that you calibrate the user's expectations that sometimes it will get things wrong. I think that is a critical part. And lastly, I think every rack system needs to have citations to the page number level, where a user can actually not just go into the PDF, but go at the very precise page and see whether you gave it the right answer or not. So building the trust is kind of going to be a back and forth of the person who's built it versus the person using it.
Great points, Amey. Han?
I think first of all, nothing is 100%. Even it's like we use a human to replace the RAG, it cannot be 100%. Mistakes will be made, right? So, I mean, that's the fact, right? And then the question is like, what is the percentage? Like 90%, 95%? I mean, and then that's a matter of, do you have an unbiased way to evaluate the overall quality of your system, right? I mean, we should. I mean, if we don't, and then it's very hard to have a conclusion whether this reg is good or not. And the next thing is, I want to say the perception of human is also plays the role here. Like for example, if I build a reg and I keep asking questions, wow, this is amazing. I think everything is just, I mean, is answered correctly. But this is actually biased because I'm just asking questions about something that the reg is good at. And then if I ask my friend or ask my wife to ask a question, and then it will break immediately, right? So I think the human's bias and human's perception is very important. So that's why I think we need to have the unbiased evaluation in place for RAG. That is very, very important. And on both, like the case the RAG should cover and should not cover. Yeah, I think that is a very, very important thing.
Absolutely. Objective criteria, very, very critical. Naveen?
Yeah, so I have 2 points to make here, right? One is the human level performance, which Han basically alluded to in his just talk right now. So that's one thing. So you should always try to measure your RAG against how good it's doing with respect to human level performance. Second thing, very important thing is the prompt which you're sending into the RAG. So what is sending in will really matter, and that's what is going to fetch back the data which you want. So the question you ask is as important as the answer you get. So you should know what question you ask and how you ask the question. And there are various ways of prompting, so we should be aware of them, like zero prompting or few shot prompting or whatever that might be. But which one suits your occasion the best, that you should be aware of, and that comes with a bit of experience as well as playing with the RAG system which you're interacting with.
Some points. So we're reaching near the end of our time, so I want to conclude with our lightning round. So if each of you in one phrase or a couple could share your one critical insight or takeaway that you'd like to leave our audience with today about scaling RAG systems. So why don't we start with Han on this one?
I think the number one question is scalability a real issue for you? Is that an issue from your imagination, or is that a real issue? If it is a real issue, I think you should categorize your use case and solve them accordingly. And there is no single solution that can solve all scenarios.
Great point. Naveen?
way I see it is a little poetically, it's going to be like data everywhere for the AI RAG system to take. So there's going to be a lot of data flowing in, and it's up to the AI RAG systems to ingest all the data and how it acts on them and how it ingests them and processes them to give out the output which you're seeking.
Absolutely. And I will give you the last word.
I'd say maybe 2 points. One is, I think it's pretty important to calculate the cost per question when you're building RAG systems, especially if it's of a chatbot-like interface, like the total unit cost that it takes to answer that. And know your data. Understanding your data is going to be the key thing to unlocking not just scale, but also user experience, latency, and all of those aspects around your RAG systems.
Absolutely. Your AI strategy is only good as your data strategy. We're definitely seeing that over and over again. So I want to thank all of our panelists today. This has been a great discussion. If anyone in the audience missed any of the webinar today, or you want to rewatch anything, the recording will be available on the same URL just a few minutes after the webinar. If you refresh the page, it will also send out an email with the recording tomorrow, and it will also be on our YouTube channel beginning tomorrow as well. We encourage you to check it out. And thank you again to our partners at Tecton, Nexla, and Galileo for making this webinar possible, as well as our excellent expert panelists today, Naveen, Han, and Amey. So thank you all, and we'll see you again next time.